Mathematical finance is also a topic in CA foundation course. It is also called quantitative finance. Mathematical finance and quantitative finance both are same. Of course, it is not called financial mathematics. It is something different. So this is one of the important topics in CA foundation, and we are going to solve one problem. Now, here in the mathematical finance, suppose one amount is suppose given. Then at a given rate of interest, this amount will accumulate to some other amount in future. Okay. So given any amount, we can find its accumulated amount at a future time, given at a given rate of interest. Similarly, a an amount in future is given, then we can find its present value, okay, at a particular rate of interest. So this is about one amount, one piece of amount. Now suppose there are different pieces of amounts at different periods, at different time intervals. That is, this such type of sequence of amounts is called annuities. Not annuities, we will say sequence of amounts. Okay. So we can find the accumulated value of this sequence of amounts at the end of at the end of the sequence of the payments. We can find the value of this sequence of amounts any point of time. Okay, at the end of the sequence, which is called accumulated value. At the beginning of the sequence, which is called present value of this sequence. Okay, we can find its value even before the present value. Okay, and we can find even after the last payment. Okay, and we can find the value of this sequence of payments in between period. So we can find the value of sequence of payments at any point of time. Okay, now we'll solve one problem. This did not appear in the CA Foundation examination. It appeared in some other examination, but of course we can expect it in CA Foundation examination also. Now let me share my screen and we will solve one problem. Yes. Yes. So this appeared in some other examination in the Math 55, some other examination, but this can very well be expected in CA Foundation. Now, hello, so my name is Bipin. Now this problem is like this. Suppose you have 15 months in which you have to save $1,800 for a vacation cruise. And if you can earn an APR, what is APR? It is annual percentage rate or rate of interest of 3.7% compounded monthly. Okay. This means the rate of interest is 3.7% per annum, but compounded monthly, that is, it is divided into equal parts, and each part is given at the end of each month. This is the meaning of this. 3.7%, that means 100 amount of 100 will earn interest of 3.7% per annum, but you will get at the end of every month 1/12 part of this. This is the meaning of it, that it is compounded monthly. So how much you should deposit at the end of each month? So here we are given 15 months and we have to, at the end of each month, we have to deposit a certain amount. Okay, so at the end of 15 months, we should get $1,800 and the rate of interest is 3.7% per annum compounded monthly. That means at the end of every month, interest is given. So how do we solve this problem? Let us see. Now see here, these are a sequence of 15 payments. Okay, made at the end of each month. $X, 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 like that. Okay, and at the end of, we can find its present value at the beginning of this sequence. We can find the value of this sequence of payments, okay, at any point of time. Just say like this, we can find it after 15 periods, after 15 months. We can find the value of this sequence of payments at the end of 15 months, which is called accumulated value. we can find a value of the sequence of payments in between this period of 15 months. And of course, we can, yeah, this is the present value, and we can find the value of this sequence of payments even before the present uh, value. That is, what would have been the value of this sequence of payments at some time before in the past. Okay. Now we want to find the future value, okay, or accumulated value of these 15 payments. Now, how do we go about it? So here, suppose that the amount deposited at each month is $X. That means at the end of each month, we deposit $X. You can say rupees X, okay, it doesn't matter. Okay. So that at the end of 15 months, we'll get our required amount. Now, here, 1 month is one period of investment because the interest period we get at the end of each month. Interest amount we get at the end of each month. Interest is calculated at the end of each month. So the period of investment taken here is 1 month. And what are the total number of periods? There are 15. 15 at the end of 15 months. Okay. There are 15 such payments. So the total number of periods is 15. So what is the rate of interest per period? We have to divide that APR of 3.7%, okay, by 12, right? So it is given by 3.7% upon 12, or it is approximately 0.003083. This is the effective rate of interest per month or per period. Now, see here. So what will happen at the end of 15 months? The each payment at the end of each month will accumulate to some different value. Okay. So $X payment deposited at the first month, deposited at the end of first month, it will amount to how much? It will amount to this much. Okay, $X into 1 plus IE raised to 14. Okay, so this is the formula for compound interest. If the amount, certain amount is invested, okay, say n periods, okay, periods could be years, months, whatever it is, and where the rate of interest is this I per period, I suffix C per period, effective rate of interest. So then the accumulated value at the end of those periods is $X plus 1 plus the rate of interest raised to the number of periods. Now $X deposited at the end of second month will amount to, just everything remains same, the number of period changes, it is 13. So and so on, we can go on calculating the accumulated value of each installment of $X. The last payment of $X will not accrue any interest. Okay. So see, it will amount to 1 plus I suffix C raised to 15 minus 15, or it will be just $X. It will not accrue any interest. So what will be the total accumulated value? Okay. It is given by this, the first amount, first installment of $X, it amounts to this much amount. Second installment of $X will amount to $X into 1 plus I suffix E raised to 13. Then third installment of $X, it will amount to $X into 1 plus I suffix E raised to 12, and so on. Last but one installment will amount to $X into 1 plus I suffix E, and the last installment, of course, it will not accrue in interest, so it will just amount to $X. Now, what is the sum of this? We can take out here, $X is a common factor, so we can take it out, right? So what is inside the bracket? It is the geometric sum of the terms in geometric progression. Okay, and what is the formula for sum of the n terms in geometric progression, where R is the common factor? So it is A into, here in the first term, see inside bracket it is 1, then 1 plus I suffix E, then 1 plus I suffix E raised to 12, I suffix E raised to 2, and so on up to 1 plus I suffix E raised to 14. Okay, so this is the geometric progression, okay, where the first term is 1 and common ratio is 1 plus I suffix C. This is the common ratio. So the sum of the first n terms in geometric progression is given by the formula first term into common ratio raised to number of terms minus 1 upon the common ratio minus 1. The same thing applies here. $x into 1 plus I suffix e raised to power 15 minus 1 upon 1 plus I suffix e minus 1. Okay. So now we put the values or put the value of I suffix e. It is this. Okay. And it comes out to this. With the help of calculator, we can see that this comes out to $x into 15.33. This is the accumulated value of all this sequence of payments. Now this must be equal to our required value. What we require at the end of 15 months is $1,800. So in order this to happen, what should be value of X? Okay. So X must be 117.43, right? So this is the each monthly installment this should be the each monthly installment so that we can have our required amount for our cruise. Okay. So thank you. This was the problem. Thank you so much.